Recent decades have seen a dramatically accelerating pace in the development and adoption of new technologies. But a gap persists in terms of adaptability. What if you can fill that gap from the comforts of your home by upskilling? Introducing PGP Full Stack Program by Let's Upgrade. The most affordable PGP Full Stack program has everything that will take you to the next step of your career via learn, build, share, grow. You earn a PGP Full Stack certificate accredited by ITM Group of Institutions, an STC, Skill in your LetsUpgrade.in.
Learn the most demanded skills in industry with 2 years of Python Django, AI/ML deep learning, data science, web development with React.js, Vue.js. You may pick any one of this track, but you will do system design, problem-solving DSA certification, cloud computing certificate also. Be the one that top companies are looking for.
Hi everyone. Good morning, very good morning. All. Hope I am audible to everyone. Please let me know if or not. Hi Gurdev, hi Pratin, hi. Good morning. Am I audible properly? Okay. Give me confirmation, guys. If I am audible properly or not. Let me know. Good morning. Okay, please someone can confirm over the comment if I am audible properly or my voice is breaking or is there any glitch on my. Please confirm. Is perfectly fine. Please let me know. Maybe you can put a thumbs up in the comment, or maybe you can put out your emojis, any favorite emojis. Oh, I got some confirmation here. Faizan and Prashan. It's and even Vishwanath has also confirmed it's audible and it's perfectly fine, right? Okay, then it's completely fine then. So a very good morning to one and all, guys, and this is day 3 of Master Data Structure and Algorithm with C++. So day 3 this session I'll be taking, guys. Amulya ma'am is not taking your day 3 session. Okay, she has got some other task to do. That's why she could not be here for the day 3, but not an issue. I'm here. I'll be taking ahead this day 3, and we'll be talking about greedy algorithm and dynamic programming in this session, right? Okay, so we are going to do a problem today, guys, on greedy, which I haven't done yet in any of this essential session. So those who are attending this session, so you are going to learn a new thing actually here. I haven't done that in any of the session yet till now. So congratulations to all of you first of all, and yeah, so thanks for joining in today. So you'll be learning a new thing today. We'll be learning greedy and dynamic, but yes, we'll do a new problem today on greedy. Okay, yeah, Akash, good morning. Okay, so before I get into this dynamic and greedy and all, can you all please mention if you have any doubt in the from anything the previous sessions? Anyone has any doubt from linked list or maybe a dynamic memory allocation, maybe pointers, maybe your loops, or maybe time complexity? Yeah, Animes, hi. Do you have any doubt? Do you want me to explain anything? Sessions, topics of previous sessions, guys? If you need it, please mention in the comment and I will take it ahead. Otherwise, we will continue with the discussion with we'll start our discussion on. Let's see. No one has doubt anything, no doubt on any of the topics covered before. That's great then. If you don't have any doubt, then that's great. You have understood everything whatever has been taught, right? So you have been time complexity was a major topic, the first topic you learned, and then you discuss about dynamic memory allocation with basic pointers and all. Then you discuss linked list, the previous session, right? Yesterday. So today it's day 3 and we'll be doing greedy and dynamic programming, guys. And the very first problem I want to pick up here from greedy is the greedy florist. Okay, there's a problem called greedy florist. You open up HackerRank, and if you search this greedy florist, you'll get a problem. Greedy florist. This is the problem of greedy programming, guys. Greedy florist. Let's understand what that problem says, and let's try to find out solution for it. Okay. So what I'll do is I'll quickly share my screen to all of you, and then we will start our discussion. Actually, just give me a moment. I'm sharing my screen. Okay. Yeah, Jainul, good morning. My screen visible? I have shared a whiteboard actually with you all. Is it visible, guys? Please let me know. Okay, yeah. So let me know, guys, over the comment if my screen is visible. I have shared a whiteboard with you all. Seems like for me, I can see it is visible, but I would like to get confirmation from clear, visible properly. Should we continue our discussion? Yes. Okay. Okay. Great. So now, we before I start discussing greedy florist and all the, before we start our session, before we start our discussion on the DSA topics concept, can you all please break the boredom, guys? I know this is like sleepy Sunday morning, so can you all please break your boredom and put out your favorite emojis in the comments, and then we'll start with a bang with a lot of excitement. We will start our session. We would start discussing actually what greedy florist problem is. Okay, so right now what we want to do to like break the boredom of the lazy Sunday morning, let's put out our favorite emojis in the comments, and then we would start discussing this greedy florist problem. Okay, right? Let me start for you all. I'll be starting with the emojis thing. So I have put here YouTube icon. Okay, can you all please put out your favorite emojis in the comment, and then we will start discussing our stuffs. Okay, I'm still waiting here. No one, no one wants to put emojis here. You're still lazy to put out also emojis. Comments. I think it's fine completely. Okay, fine. Okay, great. So now it's time we discuss our stuff. Okay, can you please all confirm if it's still visible or maybe think? Yeah, over the comments, guys. Can you please confirm? Everyone, can you please confirm? Is my video stuck or is it fine? Is it fine? Everything is fine. Am I audible properly? Anyway, I haven't seen your comments actually on chat. Okay, not able to see any confirmation from you all. Can you please all put out in the comments, please? there, or do I need to refresh this page once? Give me a moment, guys. I think my thing is stuck or something. Like, I feel like, because I am not able to see your comments. Okay. How many of you have worked on HackerRank? Worked on in the sense like you have practice on HackerRank. You know you have heard about the website, the HackerRank, and you have like practiced something HackerRank. Have you? How many of you? I think my YouTube thing is getting very sure what's happening. But yes, that's the thing. Okay, see here. We are talking about greedy programming, greedy algorithm, we can say, and greedy. System. So yes, we are talking about greedy algorithms. Okay. In greedy algorithm, we are talking about a particular problem, that is greedy florist, right? Okay, that's what we are talking about here, greedy florist. So I hope I am audible and visible properly, guys. Please let me know the comment. I think this YouTube is being weird right now. Browser not able to get stuff from, not able to communicate with you from the comment section. Anyway, so no issue. Uh, as I see, my streaming software is working fine, so I think it is visible to you properly. That's what we're concerned more about. Okay, guys. Now let's see here. So greedy florist. What is this greedy florist problem? Let's understand. So greedy florist is nothing but, guys, see, there would be some group of friends, like 3 or 4 friends, whatever you take. Some group of friends would be there, and they want to buy a flower actually from a florist, right? Okay, they need to buy flower, some certain given number of flower. Let's say n. Okay, n number or k number of flowers. Okay, let's denote here, like n is the number of let's say n is the number of what is that, n is the number of flowers. Let's take, yeah, let's take n is the number of flowers, and then k is the number of people, let's say, right? Okay, so the n is the number of flowers, let's say, and let us assume that k, which is nothing but number of friends or people or members of the group, whatever you can say, number of persons, let's say, the group, right? So we have n number of flowers that we need to take, that a group of people need to take. Okay, then we have, oh, now I see so many comments. Actually, I think my YouTube was stuck. How can I complete my day to assignment? The complete link is not working, so I have no assignment. Gurdev, don't worry. I think it would be fixed. Be fixed today. With Give me some. I'll check it out. Right. Okay. Not right now. I'll ask. Check it out. Okay. Fine. If you're not able to see the community, please put up a mail, guys, at support@letsupgrade.in. I hope you have, like, you all have this mail ID with you. Please use this up. Okay, put a mail at this support@letsupgrade.in regarding the issue you are facing in community, and it will be sorted. Okay, right? Regarding that, if you are not able to assign see the access the community and all. No, no issue, guys. We would like I'll ask my team to increase the deadline actually, okay, for your assignment submission. Okay, great. You have a doubt, Siddesh? Yeah, you can mention now. I'm able to see the comments right now. The YouTube, you can mention your doubt. Okay. Fine. So here we are talking about n as number of flowers and k as number of persons, and an array would be given. An array would be given. You can check out this problem, guys. Like on the browser, you can open a new tab and you can search for the greedy florist problem. You'll get this problem. Okay, I'm taking up the problem from like from the same page actually, from the HackerRank page, and you'll find C of n array, which is nothing but it would give you the price of each flower. Okay, x y z dot, dot. Okay, right? So let's take a particular test case, okay, particular sample case. Let's take and let's like talk about that particular problem. So right now I'm saying, let's say I have 1 and 2 and 3 and 4. Okay, right, 4 flowers I have, so n equal to 4, and let's say k equal to 4 people, 4 persons. So 4 persons need to buy 4 flowers, and the florist has this 4 kind of flowers, right? And the price are respectively 1, 2, 3 and 4. These are price, okay, cost of like each kind of flower, right? Okay, but the thing is the florist is greedy, okay, right? The whole problem is about greedy florist. So the florist is greedy. Florist, what he wants to do is he wants two things. One, he wants more customers. Also, he wants more profit. So what the florist is doing, if a person is buying for the first time, then the person will get at the cost price, the original base price, right? But let's say a person is going to buy for the second time. For example, let's say the person is going to buy for the second time, right? Let's say there's a flower of cost, what should be the cost, let's say x rupees, okay, rupees x, let's say x is the price of one flower. So this person A goes to buy this flower x, right? So this is the first time the person is buying, right? So he would get it for, right? Then there is another flower, which is y. Then if the same person goes to buy that flower, this person will not get it like with price, right? See, A has already bought a flower, he has got with rupees x, right? Okay, now A is going to buy a flower again, once again. So person A is coming for the second time, and he is trying to buy, or he is willing to buy this flower whose cost is y. The thing is that person will not get it for rupees y now, because now he is an old customer and the florist is greedy. He works in a mechanism that if a person is coming for the first time, then he will get it for the cost price. But if the person is coming from the for the second time, then he has to pay the this number of, okay, where this is the number of flowers he has already bought. Let's say there is another flower, guys, rupees z. Okay, if the same person A comes to buy one more like one more flower, whose cost is rupees z, then how much flower he has already bought? Two flowers already he has bought. So you will do plus 1 into z would be the cost price for this new flower. This is how the greedy florist makes money out of here. This is how the greedy florist follows a principle here to increase customer, also increase his profit. First time you go, you'll get it for the cost price. Second time you'll go, you'll not actually get it at the cost price. You will pay more, twice, okay, double of the price you will pay. Third time you go, 3 times you will pay. Okay, fourth time you go, 4 times of the cost price you will pay. So similarly, that is how the profit of the florist is growing. Did you all understand the problem statement? What the greedy florist, what is the florist doing here? How the florist is charging money from people? Okay, if you're going for the first time, you'll get it for the cost price, guys. If you go for the second time, it's like how many flowers you already have taken? 1 plus 1, okay, into the cost price. Okay, so you can think of, he's actually working in a mechanism called this actually, right? Maybe m plus 1 into cost price, where m is the number of flowers already taken. This is number of flowers already taken, right? When m is 0, that means you have not taken any flower from the florist. This is the first time you have come to take the like to buy a flower, right? So 0 plus 1 is 1, 1 into c is c, so you'll get it for the original cost price. But you come for the second time, then m value would be 1. You have taken already one flower, so 1 plus 1 is 2, 2 into c, so basically you will be paying twice the cost price. Everyone understood problem or not? Problem statement, did you understand the problem statement? We will solve it. We'll see the solution, how we would be go how we would be going, how we would be solving, that we would see. But the first important part is, did you understand the problem statement? Please let me know, everyone, in the comments. Okay, yeah, please guys, did you understand the problem statement, so that I can proceed with the solution, like how would we solve this problem? Okay. Yes, okay. I got confirmation from Arman. Thanks, Arman, for. So yeah, this is the problem statement. We got it. So this is how the greedy florist. This is how the florist is being greedy in making profit as well as holding the customers. Right. First time you get it for the cost price. Second time you have to pay double. Third time you go have to pay three times, like 2 plus 1. So three times the cost. So fourth time you go, you have to pay 3 plus 1, four times of the cost. Right. That's how the florist is working now. Let's take a particular test case, guys, for this, and let's try to solve this. Let's try to analyze this situation, and let's solve it, right? Okay, now here, as I said, let's take a particular test case here. I hope everyone understood the problem statement. Let's say n is 3 and k is also 3, right? Okay, and the cost price of flowers, 3 flowers, is 256. Okay, now there are 3 person, and 3 flowers need to be bought. That's what the question says. K is the number of flowers, oh sorry, k is the number of person, guys, and n is the number of flowers that has to be bought. So this is 3 flowers need to be bought, and there are 3 persons, so each person can buy one, right? Okay, that we will think of. Let's say, see guys, we are saying if a person is coming for the second time or third time, consecutive time, then the person has to pay more, okay, more than the original cost price. So if I have 3 people, 3 person in my group, and I have to buy 3 flower, instead of one person buying 3 flowers, what if each person will buy one flower, right? First person, let's say A, will pick a flower, let's say 2 rupees. Person B will pick a flower, 5 rupees. Person C will pick up another flower, the last flower, that is 6 rupees. Total how much? 13 rupees. If one person buys all the 3 flowers, so first flower he will get for 2 rupees, fine. For the second flower he will get 1 plus 1 into 5, and third flower he will get for 2 plus 1 into 6. That is how, what is the answer? 2 plus 10 plus 3, 18. So that is 30 rupees. See the difference, 13 and 30, right? So this is the difference between um, each one picking up flower, instead of one person buying all the flowers. Okay, attendance form, it's in the description, but let me give give me a moment. I'll also pin it here in the comment, guys. I posted in the chat. Also, I'm pinning it. Yeah, Gurdev, you can ask your doubt. Is if it is about the community and assignment, I've already said please put up a mail at letsupgrade.in. Okay, first. Second is if you are not able to stay, if you are still not able to see the community, fetch the community. Like if it is the case for most of you, then I'll be increasing the deadline. Okay, what is the deadline? Deadline is today is 3rd, right? So 3 more days. 13th, 14th, 15th. 15th September night would be the deadline. Actually, you have enough day. I'll try to fix the community today itself. 3 days is enough for you. That's what 15th September 11:59 p.m. would be the deadline, guys. Try to submit all the assignment by that time. But by, let's say you are not able to, let's say by tomorrow, even by tomorrow you are not able to access the community, please put up a mail at LetsUpgrade, the support at letsupgrade.in. Okay, right? Mentioning your program name and all. So, did you understand this test case, guys? We had like 3 person, total 3 persons were there, and 3 persons are there. 3 flowers need to be bought, and we have this prices of 3 flowers, 2, 5, and 6. I'm saying instead of one person buying all the 3 flowers, if each person take one flower, will be will get the cost price will be minimum. Okay, see guys, this greedy and dynamic, all this thing, these are applicable, these are applied for optimization kind of problem. Please remember this, optimization problems. Okay, what is optimization problem? You can say both greedy and dynamic, these are applicable on optimization problems. What is optimization problems? Minimize the cost, maximize the cost. Okay, not maximize the cost, maximize the profit, kind of this way, guys. Minimize the cost of buying, maximize the profit of selling, minimize the distance, okay, of traveling, kind of this. So greedy and dynamic are actually applied on this minimization kind of problem, and this is a minimization problem, guys. This is optimization problem, which says minimize the cost of buying flower, okay, from the florist. The florist is greedy, right? Okay, everyone understood the problem statement? What we have to do here, what we have to do here is we have to minimize the cost. We have to deduce a way out here how we can get minimum cost. Here we have talked about 2 ways. If one person buys all the 3 flowers, what is the cost? If each person takes one flower, what is the cost? Here we saw that if all the 3 person buy 1 flower each, then we are having minimum cost. That's the whole point here. That's the whole thing we have to do here actually. Okay, so instead of one person taking all the 3 flowers, we have to take, each person will take one flower. Okay, right? Now this is one test case. Fine. What about let's change the test case, guys. I hope you understood this test case. Okay. See, first flower 2 rupees original cost. Second flower, already 1 flower has been taken, so 1 plus 1 into 5. Okay. For the third flower, already 2 flowers had been taken, so 2 plus 1 into 6 into cost price. That's what we had discussed, just now discussed, right? So that's what we are getting here, which is by which we are getting more cost. We have to go for this. Okay, each person will take flower. Okay, 0 plus 1 into 2, 0 plus 1 into 5, and 0 plus 1 into 6. That would be total would be 13, because these are different persons, right? Different person. So for each one of them, they are coming for the first time, so they will get it at the cost price, original cost price. Okay, now let me clear this out. Let's talk about another scenario. Guys, I hope you are following. Are you all with me up to this point? Please let me know. Now let's say n equal to 3 and k is equal to 2, guys, right? We have three persons, sorry, two persons and three flowers to buy, and the cost price given as 256. Now the number of person is less than the number of flowers needed. That means at least one person need to repeat, right? Like at least one person has to buy two flowers. We have two person and we need three flowers, so at least one person has to buy two flower, and when the person would buy the second flower, it would cost more to him. Am I correct, guys? Is it clear? Understood what I'm saying now? We have two person and we need three flowers. So two person, three flowers, one person will buy one, second person will buy another. Okay. Again, the first person or the second person has to buy the other flower, right? At least one of them has to buy two flowers. And when that person would buy the second flower, he has to pay more than the cost price. And we need to minimize our cost price here. Understood, everyone? This test case, this is another test case. Previous, there was no issue, there were three person and three flowers was required, so each person bought one flower and it was sorted. But now we have only two person and we need three flowers, so at least one person has to buy two flowers, and when that person will buy the second flower, it would cost more. And the whole point of this question is minimizing that cost. Understood, guys, up to this problem statement, this test case? Did you get it? If you understand the problem statement, if you understood the problem statement, then we can talk about the solution. Okay, no point of talking about the discussing the solution if you have not get the question itself, right? Okay, so we have now two person, three flowers we require, each flower cost we have, and we have to minimize the cost. Can anyone give me, like Aman or Gurudev or Mohan or Siddhesh, can you mention here what should be the, let's say, let's name A and B, the person. Okay, there are two person, right? Let's name it A and B. Now if person A, okay, person A buys one flower of price 2, fine, okay. Person B would buy another flower of 5 rupees 5, okay. Now any one of them has to buy the third flower, maybe A, it may be B, doesn't matter, because let's assume that A is buying the next flower, okay. So what would happen here? So the cost would be 1 into 1 into 6. What is the total cost, guys? So here it is 12 plus 2 14, right? So here it is 14 and here it is 5, so total is 19 rupees. You're getting 19 rupees, but you need to think, is it the minimum cost? Is it the minimum cost, or do we have another way out of this? Is it the, like, we have to pay anyway, the minimum cost is 19, or is there any other answer to this? Is there any other way out to this? Okay, just give me some answer, guys, over the comment. It is for sure one person has to buy two flowers, and the person who would buy the second flower has to pay more. That is for sure. No one can change that. Is it correct the way I have done? Okay, the flowers I have taken, and I'm getting a minimum cost price. The cost price is 19. This the minimum? Okay. Remember, guys, we don't have to find the cost. The thing is, the question is minimize the cost. Okay. Let me give you a scenario here. You know this, right? You are buying a flower and you go to buy the flower second time, and you have to pay more for it, right? Let's take a practical example. You have to buy, let's say, three commodities, guys. Okay, you have to buy three commodities, A, B and C, right? Three commodities. I'm writing it down. A, price of A is, let's say, 100 rupees, price of B is, let's say, 50 rupees, and the price of C is, let's say, 200 rupees, for example, right? Yeah, Aman, yes, exact. Sorry, Arman. Yeah, it's exactly. Even if the person B, even if person B buys the second flower, the cost would be same. Yes, I got it. Okay, but the thing is it minimum? This is not minimum. The thing is that Gurdev, I have already mentioned this. How many times you are asking? 3 more days, 13th, 14th, and 15th. 15th September, 11:59 p.m. is the deadline for your assignment. Okay, if you are not able to access the community by today or tomorrow, please put a mail on support@letsupgrade.in. Okay, and it will be sorted. Let's focus here on the question. So now, see guys, you have three commodities. You have to buy three commodities like A, B, and C. A price is 100 rupees, B price is 50 rupees, and C price is 200 rupees. Right? Okay. And there is a condition: you can buy one commodity today. Okay. Today, on a given day, or let's say, yeah, on a given day, you can buy only one commodity. Right? Okay. And it is said that tomorrow, this today, it is said that tomorrow the prices would increase by 50%. For example, tomorrow maybe 2 days after, the prices would increase by 50%. Okay, so what would be the, if the prices would increase by 50%, what would be the new price of A? New price of A would be 150, right? And this would be 75, and this would be 300, right? Next day, if you go to buy this commodities next day, okay, then this would be the prices of this commodity A, B, and C. You know this is given information that tomorrow all the commodities will, in the prices of all the commodities will increase by 50%. Okay, if you know this, which one commodity will you buy today, guys? Which one commodities uh, would be like you will buy? Which commodity you will buy today? This is the information you have with you. You know that next I can buy only one commodity today. Okay. Next day, 50% the hike, 50% hike, price will be increasing by 50%. So the new price of this commodity will be this 150, 75, and 300. So which one I should buy today if I want to minimize the cost? Can you tell me? A, B, or C? Which one you would buy today, guys, in order to minimize the cost? Okay. I expect some answers. You got right. You got it right. The practical scenario. You have to buy some commodities A, B, and C. Prices are given 150 rupees and 200 rupees respectively. You know that tomorrow the prices are going to increase by 50%. The condition is you can buy only one at a time. One commodity at a time you can buy. If you are buying commodity today, one commodity, you cannot buy any more commodity today. You will buy next day. Tomorrow you will have to buy the next commodity. On a particular day, you just can buy one commodity. Aman says B. Uh, Arman, right? Okay, sorry, Arman. Arman says commodity B he would buy today in order to minimize the cost. Anything else? Anyone wants to answer it differently? Anyone has a different answer to this? Okay. Just think about it. I have given the price of today and the price of tomorrow, guys. Okay. Which one you would buy today in order to minimize the cost? Total cost. In order to minimize the total cost. Anyway, you have to buy three commodities. You need all the three commodities. Okay. And next day, let's say another 50% will increase. So it would be how much? To next day, like next day, 150, 50% is 225, right? Like total, it would be 75. It would be, you can say, 112.5 or something, and this would be 450 rupees. Day after tomorrow. Okay? Day after tomorrow. This would be the new price. Mohan says C. Okay? Correct answer. Mohan, it's correct. Yes, Harsh, it is correct. Okay, you'll buy commodity C today. Okay, I'll buy commodity C today. See the difference, guys. Tomorrow it would be 300 rupees more. Okay, if you keep it for later, 450 rupees, 250 rupees difference from today's price. So what I'll do is, in order to minimize the total cost, I'll pick up the highest, I'll pick up the commodity with highest price today, so that I'll not incur more hike in price next day. Okay. Next day you'll buy the next maximum commodity, that is 150 rupees. Okay, and then next day you'll buy this one, because the increase would be less, hike would be less there. This would be the total minimum cost. Okay, you cannot have less cost than this, you cannot have. Okay, right? So you know the price is increasing, guys, right? You know price is increasing day by day, so you'll buy the costly item today first, so that the increase in the price would not be much. Keep the commodity which cost is more very high, if you keep it, if you don't take it today, if you keep it for later, then hike on it 50% on it would be more. Okay, obviously it is pure mathematics. 50% of 50 is 25 rupees, 50% of 200 rupees is 100 rupees. You'll get 100 rupee hike, whereas here you'll get only 25 rupees hike. Okay, for the next day. So you will pick up the commodity with highest price today, and you will keep the commodity with low price for next day, for future, for next day. Let it be clear, guys. Is it clear what I'm talking about here? How we can minimize the cost? In order to minimize the cost in this situation, you have to pick the element with maximum cost first. Okay, understood? Is it clear, guys, or not? Is it clear? Let me know in the comments. Why should we take the commodity with highest price today? Because hike on it would be more next day. I want to keep it at the cost price, at the less price. I want to keep it today. Okay, right? Is it clear? Please let me know. Clear? Okay, great. So, fine. Now, if you understood the problem, guys, this commodity wala problem, whatever I have just mentioned, this is similar to this greedy florist problem. Okay, because the cost of the flower will increase next time. Cost of the flower will increase every next time you come, every consecutive time you come, the price of the flower is going to will increase, actually is going to increase, right? So what you should do is, you should pick up the flower with maximum cost first. Okay, then keep the flowers with with lesser cost for later. That's what you should do here. See, guys, this greedy algorithm. Okay, greedy algorithm, the name is greedy algorithm, right? It is greedy about the solution. Okay, it is greedy about the solution. So it will always pick up the best element, actually. Okay, it will always pick up the best element. Check this out. Greedy algorithm, greedy algorithm is greedy about the solution. it follows a greedy approach actually. Okay, follows a greedy approach. It is greedy about the solution. It will pick the best element every time. Best element every time, it will pick up the best element. What is this best element? See guys, best element, it depends on the situation actually. It differs. Okay, it differs problem to problem, right? Like if I talk about maximize a profit, so one would pick up this algorithm will pick up the element with highest profit first, maximum profit first. Okay, let's say there are two products. You are getting 10 rupees profit by selling one product, and you are getting 8 rupees profit by selling second product. Okay, other product. So greedy approach says if you want to maximize the profit, pick up the element, pick up the item first which has maximum, which will give you maximum profit. That is the best element for it. Okay, so every time it will pick up best element guys, and best element will differ problem to problem. If you are talking about minimize the cost, then mostly generally what it is you will pick up the element which has minimum cost first. That would be the best element for the greedy algorithm. So it will pick up the best element, next time next best element, next time next best element, okay, next time next best element, and that is how it works. That is how it will go on. Okay, this is how greedy algorithm works. It is greedy about the solution. It will always pick the best element. Okay, best element differs from problem to problem actually. Okay, if it is maximize the profit, then best element might be the element with highest profit. Okay, it will pick up the element with highest profit first, then it will pick up the element with next highest profit, then it will pick up the element with next highest profit, so on. Okay, right? Moment. So if you're talking about maximization problem, maximize the profit, and you have items, profit of item as 10, 8, 7, 5, 6 and all, so it will pick up first this item with profit 10, then it will pick up this item with profit 8. Let's say you can take only 3 element guys, so it will pick up this 10 the items with profit 10, 8 and 7, because best element for greedy approach is this first 10, next best is 8, next best is 7, because here the problem is maximize the profit. So to maximize the profit, best element it will pick up. Best element here is nothing but the element with highest profit. Okay, so this best element will differ problem to problem. Like if we are talking about minimize the cost of buying products, 3 products, and the products prices are given as, let's say 5, 9 and maybe 13 for example. These are prices of the product. So the question, let's say it is saying you need to buy 3 products, but you need to minimize the cost. So what it will do is it will first pick up the element with minimum cost first, then the next best element is 5, then the next best element is 7. So total cost is 5, 3, 8 plus 7, 15 rupees is the minimum cost guys. This is as per the greedy algorithm. Here guys, in the greedy florist problem, even here we are picking up the best element. Every time we are picking up the best element. It is just in this situation the best element happens to be the flower with maximum cost first. Okay, got it? And we know we have understood why it is best element, because if you don't pick the flower with highest cost now, then next time the hike would be more, the increase in price would be more. So right now the best element is the flower with highest price, will pick up that. And the next best element would be the flower with the next highest price, will pick up that. That's how greedy algorithm works. Greedy algorithm, it is greedy about the solution, so it picks up the best element always guys, always it picks the best element, right? Okay, let's complete our discussion on the greedy florist actually, right? Okay, the number of flowers was 3, and number of person was 2 person, and prices were 2, 5 and 6, right? What we will do, we have 2 person A and B. So A, the first person should pick up the flower with maximum price, that is 6. So 0 plus 1 into 6, right? Second person would buy the next best element, that is the flower with next highest price, that is 5 rupee. Then either A or B, let's go with A, circular manner. A will buy the next flower, that is 2 rupees. Okay, what is the total cost now? So here 6 plus this is 4, 6 plus 4, 10, and this is 15, right? Total, oh, this is not 15, this is 5. 5. Total is 15 rupees. This is the minimum cost, guys. This is the minimum cost. So here best element is the flower with highest cost. Next highest, this way. Clear? Is it clear, guys? Clear? One assignment for you all. Assignment is you need to submit the minimum, work it out and submit the minimum cost given the information. Let me write it. Number of flower need to buy is 5. Number of person is, let's say, 3. And what is this? Prices. The cost of each flower is 1, 3, 5, 7, 9. Prices of 5 flowers are given, guys. 1, 3, 5, 7, 9. Okay. So you need to give me the minimum cost, okay, applying greedy approach by greedy mechanism approach or greedy algorithm. Applying greedy algorithm, you have to give me the minimum cost. Same way, guys. Okay, same way you have to work it out and you have to submit. Okay, show the calculation and all, everything. Okay, clearly mention everything and submit, and finally the result, like what would be the minimum cost. Okay, right? This is greedy flourish for you, guys. This is greedy algorithm for you. Okay, what you can do is, after this session you can directly head on to the HackerRank. You can search for this problem. Also you can solve it. You can write the code. You can solve it. Okay, right? So right now we are done with the greedy flourish. Okay, right? Let's now discuss some crucial information about greedy algorithm, guys. As I said, greedy algorithm is greedy about the solution, and it always looks for the best element. It might happen that greedy algorithm, not solution, greedy algorithm may not lead you to the solution. Greedy approach may not lead you to the solution, guys. Okay, so it's like what I'm trying to say. Let's figure it out. Let's talk about a real-time scenario. Let's say you want to go to the market. There is a main road way. You go to the main road and you can, and there is another shortcut way. Okay, which goes like between the village or something, okay, by the village or something. So if you calculate the distance, you go by the main road, the distance is more. Okay, let's say it is 3 kilometer, let's say, right? And if you go by this another kacha road, the distance will be 2 kilometer. So the problem is, it might not, even if the distance is less here, it might not guarantee you, might not assure that you will reach faster, reach sooner to the market. Okay, main road is a Pakka road, and can just move bit faster and reach the marketplace sooner. Okay, it might happen that this Kacha road is there is some construction work or the repairing work is going on, and you will go and you'll get blocked there. You might have to return back and again have to seek the main roadway, right? That has happened to me. Like some few years back, I had went to, like, sorry, I had gone to a place. And I'm not sure whether you know that place or not, Raurkela in Odisha, and I followed the Google map and it showed me some way between this fields and all. Then I ended up at a railway track. I didn't find any way to go further. What I had to do is I had to come back again and had to go through the main road again. Okay, right? That happens. So greedy shortcut is not always a shortcut. Okay, right? So greedy algorithm, it follows a greedy approach. It is always greedy about the solution. It is always greedy about taking up the best element. But the thing is that might not lead you to the solution always. Okay, that might not lead you to the solution always. Let me give you one more scenario where you can understand, guys. Okay, see, it is a coin change problem, actually, very famous problem. Coin change problem, very famous problem of greedy, actually. Okay, let's talk about there are in an ATM, or let's say yeah, in an ATM there are various notes of denomination, say 1 rupee, 2 rupee, 5 rupee, 3 rupee, 3 rupee, 100, 200, 500. These are the available denomination, guys. Okay, 1 rupee note, 2 rupee note, 5 rupee note, 20 rupee note, 50 rupee note, 100 rupee note, 200 rupee note, and 500 rupee note. Okay, maybe I can increase one more. Maybe let's take one more 1000 rupee note, and you have to withdraw, let's say 728 rupees. You need to withdraw 728 rupees, and the problem is, what is the minimum number of coin? This coin change problem, guys, this is nothing but minimum number of coins required to withdraw 728. What would be the minimum number of coin to take 728? Each denomination is available in plenty. Each denomination, like 1 rupee, there are a lot of 1 rupee coin, there are a lot of 2 rupee coin, there are a lot of 5 rupee coin, there are like, enough number of 20 rupees coin, 50 rupees coin, 100 rupee coin. But what coin you will take, how many, so that you will have minimum number of coins at the end. So it is about a minimization problem, again optimization problem, minimizing the number of coin to have 728. Because one can take 1 rupee, 1 rupee coin, 728 1 rupee coin one can take, that would also make 728 rupees, right? Okay, but that certainly is not minimum coin, that is, I guess, maximum number of coin. Okay, that is maximum number of coin. If I take 1 rupee coin, 728 1 rupee coins, if I take, that would make 728. Amount is made, but that is not minimum number of coin, right? So we need to minimize the number of coins. So here the best element is nothing but the highest denomination. Okay, the coin with highest denomination is the best element here. So it will try to take this coin with highest denomination, that is 1000. But the problem here is 1000 cannot be taken. Amount is less than the denomination value. So I cannot take 1000. Can I take 500? Yes, I can take 500. So 728, let's say this C is the number of coin you are taking. We're taking one 500 rupee coin. So what is the rest amount you need to make? 228. You need to make more 228 rupees. Can you take more 500 rupee coin? No, I cannot take more 500 rupee. Can I take 200 rupee coin? Yes, I can take a 200 rupee coin. Total number of coin is 2. I'm taking one more 200 rupee coin. So the rest amount I need to make is 28 rupees. Right? I cannot take any more 200 rupee coin. Can I take 100 rupee? No, I cannot take 100 rupee. Can I take 50 rupee? No, I cannot take. Okay, because 50 is more than 28 rupee. Can I take 20? Yes, I can take. So 28, I'm taking one more coin of 20 rupees. So I need to make 8 more rupees. Okay, can I take a 5 rupee? Yes, I can take a 5 rupee. So I'm taking one more coin of 5 rupee. So that is like, I need to make 3 more rupees. I need to make. Can I take a 2 rupee coin? Yes, I can take. Okay. Can I take a 2 rupee coin? Yes, I can take. The rest of the amount I need to make is just 1 more rupee. I cannot take more 2 rupee coin. I can just take one rupee coin. So that will make my amount. See, total amount now is made 728. I have covered with total 6 coins. 6 coins. Okay, total 6 coins, guys. We minimum number of coin is 6 in order to make 728 rupees. Yes, Arman, yes, exactly, you're correct. So this is fine, this is working, this greedy approach is fine here. Here the best element is the coin with highest denomination. Everything is fine. Let me give you one more scenario and you tell me. Okay. Say 5, 4, not this one. One more test case I'm giving you. Then, yeah. Okay. This is the available denomination, guys. And the amount you need to withdraw is 11 rupees. 11 rupees. Just follow the same greedy logic and let me know, guys. Okay. You know what is the number of coin you are getting by applying this greedy logic. Let's say I'll sort it and write. Sorted manner I'm writing. It will be easier for you to follow the greedy approach. What is greedy approach? It will always pick up the best element. And here, what is the best element, guys? As per whatever we have discussed, best element is the coin with highest denomination. Obviously, the denomination value should be less than or equal to the amount. It should not be more than, right? So as per this logic, as per this greedy algorithm, I want this amount 11 rupees, right? I can take 7 rupee. Okay, I'm taking one coin of 7 rupee, fine. But the remaining amount I need to make 4 more rupee. Can I take 6 rupee? No. Can I take 5 rupee? No. Can I take 3? Yes, I can take. So one 3 rupee coin. Okay, right. So I need just one more rupee. I will take one more coin, right? So total 3 coin. With 3 coin, I'm making 11 rupees. But certainly, this is not the minimum number of. It's quite evident here. Okay, it's quite evident. If I just take 6 rupee coin and a 5 rupee coin, it will make 11 rupee. That is 2. You can see here, it is very visible. Okay, it is visible to us that if I take only one 6 rupee coin and one 5 rupee coin, then we are getting the solution here. Like we are getting with with 2 coins able to make 11 rupees. But as per the greedy algorithm, it is giving me 3 coins. Not correct. Okay, that's why I'm saying, guys, greedy approach will not always give you the solution. It's always greedy about the best element, but that may not lead you to the solution always. Like here, see, greedy is failing. The previous case, it was fine, it was working, and we are getting 6 coins, and that was correct. But in this test case, this particular test case, he is failing. Okay, understood, everyone? Why I'm saying that greedy algorithm may not lead you to the solution always. It might fail somewhere. It might give you a result, but that result might not be the correct solution. Like here, in this problem, we are getting 3 coins, but that is not the solution. That is wrong actually. It is visible, it is quite evident. If I take only 2 coins, one 6 rupee, one 5 rupee, make me 11 rupees. That will make total of 11 rupees. I don't need 3 coins. Minimum 3 is not the minimum number of coins required to make 11. Actually 2. Answer should be 2. Greedy here is giving wrong answer. Understood? Understood the loophole, guys, in a greedy algorithm? Yes? Okay, great. Now what we would do, how would we find a solution for this? We would find a solution here using dynamic programming. Okay, right? Available denominations are 7, 6, 3 and 1. Amount I need to make is 11 rupees. So we would find this solution for this problem, minimum coin change problem, using dynamic programming, guys. Okay, so dynamic programming again is applied on optimization problem. This is also optimization problem, guys. It is like minimize the number of coins required to make a particular amount, right? Okay, That's what we will do here. How do we go for dynamic programming? What exactly dynamic programming follows? Greedy, we understood, it is greedy about the solution and it always take the best element. So how does this how does this dynamic programming works? So guys, dynamic programming it uses something called, it uses a principle, or it works on something called memoization. It is not memorization, guys, it is memoization. What exactly is memoization? Okay, so it says that, I'll come to this memoization. Okay, I'll come to this memoization, guys. Let's see where dynamic programming is applicable, where we can. Okay, first condition, obviously, like the problem is an optimization problem. Okay, that is being done, that is already understood. Dynamic programming and both greedy, they're applicable on optimization problems. The problem is optimization problem, but there are some added condition which should be satisfied in order to apply dynamic programming. What? Let's see this. The problem should be like, you should be able to divide the problem into sub problems. Okay, small sub problem. The entire whole big problem can be divided into small sub problems. Okay, right? And sub problems should be repetitive in nature. Repetitive sub problems, right? Sub problems should be repetitive, overlapping. Okay, what do we mean? What do I mean by this repetitive sub problems? I mean to say here, let's take an example of this Fibonacci, guys. Fibonacci, let's say, okay, I'm clearing this screen. I'll talk about Fibonacci problem, the recursive Fibonacci problem, and I'll make you understand what is called this sub problem and what is this repetitive sub problem or overlapping sub problem. These two conditions should be followed, guys. If you want to apply dynamic programming, then these two conditions is necessary. The big whole problem, you should be able to divide it into small suboptimal problems. Also, those suboptimal problems should be repeated, should be overlapping. Let's understand what is that, what I'm talking about. Okay, let's take this example of Fibonacci series. Okay, I hope you all know the Fibonacci definition, actually the recursive definition of Fibonacci series. Okay, it is nothing but, it would first like fib of 4 plus fib of 3. Okay, now this is fib of 3 plus fib of 2. This is fib of 2 plus fib of 1. This is fib of 2 plus fib of 1. This is fib of 1 plus fib of 0. This is fib of 1 plus fib of 0. This is fib of 1 will directly return something. Don't need to call any more function. This fib of 2, again this would be fib of 1 plus fib of 0. Fib of 1, it would directly return. See guys, what we are doing here is, what I need you to understand here is, the problem was this: we find the Fibonacci series of 5 terms or something that was divided into small sub problem. Okay, that was divided into small suboptimal problem or sub problem, and we will find solution of each small problem, sub problem, and we'll combine them together to find out the solution of the bigger problem. That's what dynamic programming does. Okay, so problem should be able, you should be able to divide a problem into small sub problem, right? Okay, the sub problem should be repetitive in nature. What we will do is, we'll find solution for those small individual sub problems, and finally we'll combine those solutions together to find out the solution of the bigger problem, whole problem. That's what dynamic programming does. But here I want to mention you what exactly I mean by this repetitive or overlapping subproblem. Repetitive or overlapping subproblem means, guys, You see here, same sub problem is being called again and again. This fib of 1, fib of 0, here fib of 2 is there, like here again fib of 2, again here fib of 2, right? Okay, see here this is fib of 3, again here we have fib of 3. This is repetitive in nature. The problems, sub problems are overlapping. We are getting repetitive sub problems. If this is the case, guys, you can apply dynamic programming. Okay, right? Understood? One problem divided into small problems, small sub problems, suboptimal problems, and those suboptimal problems, those small sub problems are repetitive here, are overlapping here. In this case, in such cases, dynamic programming is applied. Okay, first and foremost, optimization problem. Then these two conditions should be there. Okay, so what exactly dynamic programming does here? What is the benefit of dynamic programming? Let's understand that. So the benefit of dynamic programming is, okay, once you have found, let's say here fib of 1 you found, fib of 0 you have found, guys, you store in some table actually. Okay, store the result in some table here. Okay, some result, whatever result you store in some table, you found, then you will also find the fib of 2 here. You'll get the result for fib of 2, store it in fib of 2, whatever the value is, store in fib of 2. Next time when you come across this fib of 2, instead of recalculating the result, you just take the value stored in the table and use it here. You don't have to call this two more function. You don't have to call these two function anymore, because fib of 2 you already have calculated, the answer is with you, you have stored in some table, and you will just reuse that solution again. This is memoization, guys. Okay, store the previously calculated result, store the solutions of the sub problems, and whenever that sub problem appears again, you just use that solution here instead of recalculating it. This is the whole point of dynamic programming. This is what dynamic programming is doing. Okay, instead of recalculating, it is using back the already calculated results. This is memoization, storing in table, calculate something, store that in a table, tabular form, right? Later when you come across the same problem, you just use a solution there. This is memoization. Clear, everyone? Is it clear where we can apply dynamic programming, and what are the necessary conditions, what principle dynamic programming follows? Okay, clear? Is it clear? So now we don't have to like calculate again fib of 2 or fib of 3. Once if I calculated fib of 2 and fib of 3, later on anywhere I get that fib of 2 or fib of 3, I'll just use it. Okay, right? I hope you got it, guys. Let me know, guys, in the comments. Is it clear? Is it clear, guys? Please let me know. What is dynamic programming? When, like, where it is applied? What follows? What principle it follows? How actually dynamic programming is applied? What it does? This whole thing is about memoization. Something called memoization. What memoization is? Understood, right? Everything. Just let me know in the comments so that I would solve this minimum coin change problem using this dynamic programming, which would, like, you would understand it more after it. Clear? Okay. Now let's solve that minimum coin change problem using dynamic programming, and let's see how this would give us a solution actually. Okay. So now We have denominations. We had 7 rupee. I'll change it, guys. I'll let me take few like a small example. I don't want to take much time, so let's take a small example actually. For this is the available denomination, and amount I have to withdraw is 7, let's say. Okay, so what dynamic programming does is, the first thing, foremost thing, you would draw a table, because we'll be storing the result in those table actually. Okay, draw the table first. 1, 4 and 5, these are the denomination, right? This is zeroth column, say. I think 0 row should also be there. 0 row, 0 column. I'll tell you. 0 column. 1, 2, 4. Just give me a moment, guys. I'll explain what I'm doing. Okay. So see this row. Okay, this rows. This is nothing but the coins denominations, available denominations, guys. 0, 1, 3, like 0 rupee coin, 1 rupee coin, 3 rupee coin, and 4 rupee coin, and 5 rupee coin. But what exactly this means? When you are here, in this row, it means you have plenty of 1 rupee coin. Okay, when you are here in reach this row, it means you have plenty of 1 rupee coin and also 3 rupee coin, both coin you have. When you are at this row, it means you have 1 rupee coin, 3 rupee coin, and 4 rupee coin. Abundance of each coin, guys, like infinite number of 1 rupee coin, infinite number of 3 rupee coin, and infinite number of 4 rupee coin. Okay, when you are at this row, it means you have 1 rupee coin, 3 rupee coin, 4 rupee coin, and 5 rupee coin. You have every kind of coin, all the possible denomination you have, given denominations. Okay, this is what you need to understand, this is what you need to consider here. What is this column? This is nothing but the amount. Okay, zero amount you need. If you want to make zero amount, if you want to make 1 rupee total, if you want to withdraw 2 rupee, if you want to withdraw 3 rupee, if you want to withdraw 4 rupee, 5 rupee, 6 rupee, 7 rupee. Last me question had asked me to withdraw 7 rupee. Why I'm writing 0 on every possible thing, 1 2 3 4 5 6 7? Because, guys, dynamic programming is a very generic kind of solution actually. Okay, this table, even if you, like, let's say amount, next time the amount is 6 rupee, let's say. Okay, don't have to change it anything here. You just remove this 7th wala column, this column with say numbered 7, the amount 7, you remove it, and this would work for the 6 rupee. If the amount given is 10 rupee, just add more column 8 9 10. That will give you the solution for 10 rupee coin. Get 10 rupees, total 10 rupees. So it's a kind of generic thing. So you have to write all possible amount actually, starting from 0. All possible amount you should write. Okay, fine. Now let's get to the solution quickly. First of all, let's come to this 0 column. 0 column means you want 0 rupees total. How many coins you will take? 0 0, right? Everything, it would be 0 here. You want 0 rupees, you cannot take any coin, so everything would be 0 coin. Similarly, if you are at this row, guys, you have only you have coins of 0 denomination. How many coins of 0 denomination you can take? 0. You cannot take any coin of that. Okay, right? This is dummy 0 and 0 column and 0 row. We are taking it for some purpose actually. Okay, we will need it, guys. Okay, right? That's why always take this dummy, the bottom thing. This is known as bottom up approach of dynamic programming. Bottom up approach, from lowest value we are going to higher value. Bottom up approach. Okay, right? That Fibonacci, let's forget that. Focus here. Bottom up approach. We are starting from 0 and we'll go till the amount 7. Okay, right? So here the 0th row and 0 column would be 0 0, because we cannot take any coin of 0 value and we cannot take any coin to make 0 rupees. So 0 column and 0 row as 0. Now we are at this column. We want 1 rupee. Okay, we want 1 rupee, and now we are at this row, guys. We are at now this row. We are now this row. So we have plenty of 1 rupees coin only, and I want 1 rupee total. How many coins will take? One. Will take one rupee coin. That would make your amount. Fine, that's great. Okay. Now you are here at the second column. So you need now 2 rupees total, and you are at the same row here. Okay, you are in the same row here. You have 1 rupee coins, and you total need 2 rupees total. So how many coins you will take? You will take 2 1 rupee coin. Similarly here in this column, you will take 3 1 rupee coin to make 3 rupees. Here you will take 4 1 rupee coins to make 4 rupees. Here you will take 5 1 rupee coin to 5 rupees. Here you will take 6 1 rupee coins, because you don't have any other option. You are in this row, guys. You only have 1 rupee coins. Okay. Similarly, for 7 rupees, you will take 7 1 rupee coins. Okay. Now let's go to the second row, next row. In the next row, you have 1 rupee coin and 3 rupee coin. You have option of 2 coins taking. You have option to take 2 coin. Either you will take 1 rupee coin or you will take 3 rupee coin. Each one is available in infinite number. You'll assume. Again, here you want total 1 rupee coin. Can you take a 3 rupee coin? No, right? We cannot take a 3 rupee coin. So what we'll do in this case, if you cannot take a 3 rupee coin, just copy the previous value. Previous value means this one. Just copy here. Okay, just copy. We can take only 1 rupee coin. Now, second column here. You need total 2 rupee. Can you take a 3 rupee coin? I cannot take a 3 rupee coin. So just copy the previous value, that is 2. Copy it. Now you are at this column 3. That means you need total 3 rupee. Okay. And you are at this row. That means you have 1 rupee coin and 3 rupee coin. Can you take a 3 rupee coin to make 3 rupees? Answer is yes, I can take. The amount you wanted is 3 rupees. Okay. Now you are taking 1 coin of 3 rupees. What is the rest amount to be made? 0. Okay, right? So for 0 more rupee, what is the amount? What is the number of coin you will take? Okay. For 0 rupees, guys, what you have to do is just come to, in the same row, just come to the 0th column and pick up the value, whatever is written. That is 0 plus 0. Total is 1 coin. Okay. This is not, we have not got yet the answer. Now we have got 1 coin. What is the previous result? 3 coin. Which one is minimum? 1. You will write the minimum actually. Okay, you understand it. I know this is a bit confusing for the first time. When I'll solve, when I'll fill the cells coming out, basically the same process I'll follow, guys. Same thing I'll be doing. Please be with me. You'll understand at a point of time. Okay. Now we are at this 4th column, or like column 4. That means we need 4 rupees. Can I take a 3 rupee coin? Can I take a 3 rupee coin? Yes, I can take 1 coin of 3 rupees. What is the remaining amount I have to make? 1 more rupee. To make that 1 more rupee, what is the number of, what more number of coins I have to take? Okay, to make that 1 more rupee, to make the remaining amount, what is the number of coin I require? Same thing, guys. What you have to do, in the same row, come to the column 1, the 1 rupee column, and the value here is 1. So 1 more rupee. See, we are using the previously calculated values. We are not calculating it again. We already know to make 1 rupee, the minimum number of coins we already have stored. So we are just taking that, and the answer we are getting is 2 here. So 2 we got this time 2, previous value was 4, which is minimum. 2 is minimum, so write 2, because the question is about minimizing the number of coins. Will not take 4, rather will take 2. Okay, similarly guys, if I now want to make 5 rupee, can I take, I am at this row, that means I just have option of taking 1 rupee coin or 3 rupee coin. Can I take a 3 rupee coin? Yes, I can take. So you take one coin, of 3 rupees. What is the remaining amount? 2 more rupees. What would be the number of coins to make the remaining amount? Just go to the second, in the same row, go to the column 2. Okay, what is the value there? 2. Okay, so 1 plus 2, that is 3 you are getting. Total 3 coins. What is the previous value? 5. Now you are getting 3. Minimum is 3. So write 3. Okay, see guys, for the remaining amount, we actually we had to make 5 rupee. I have taken one coin of 3 rupee. The remaining amount is 2. I didn't calculate it again. I didn't calculate for 2 rupees what is the minimum number of coins. I just went back to the table. I just looked on to the previous value, previous solution stored for 2 rupees. I just picked up from there. This is memoization. Okay, and then I just compared which one is minimum, the current solution which we are getting or the previous value which we had. Whichever is minimum, I'll pick that, because the problem is about minimizing the number of coins. Similarly, now here at 6, okay, 6 here, I want to make 6 rupee. Okay, I want to make 6 rupee here. Can I take can I take a 3 rupee coin? The answer is yes, I can take a 3 rupee coin. I'll take one 3 rupee coin. What is the remaining amount I need to make? 4 rupees. So what would be the what is the remaining number of coins to make 3 more rupees? Same thing. Just come to the column 3 here. Okay, column 3 here. This would give you the number of coins required to make 3 more rupees, and the value is here 1. So 1 plus 1, that is total 2 coins you require. What is the previous value? 6. What is the current result? 2. Minimum is 2. So you guys, you need only 2 coins to make 6 rupees. That is, you are taking 2 coins of 3 rupees. Okay, 2 coins of 3 rupees, that will make 6 rupees. Fine. Now, in order to make 7 rupee, you want 7 rupee. Let me clear this out. Basically, I'm doing the same step, guys. I'm not doing anything else. So I now need 7 rupee total. Can I take can I take a 3 rupee coin? Answer is yes. So I'll take one 3 rupee coin. Remaining amount is 4 more rupee. I need 4 more rupee. Right? Okay. To make 4 more rupee, what is the remaining amount of coin? What is the remaining number of coin? Same thing. Just go to the fourth column, the column 4. Okay. Take the value there. Take the value from there. That is 2. So 1 plus 2. Total 3 coins I need. What is the previous value? Previous value is 7. 3 is minimum. So by taking 3 coins, I can make 7 rupee. Okay. And 3 is not the solution, guys. It is actually up to now. Okay, we are at this row. That means if the available denomination is 1 rupee and 3 rupee, if you have only 3 rupee coin and 1 rupee coin, then to make 7 rupee, you will need 3 rupee coin minimum, like 3 coins minimum, sorry, not 3 rupee, 3 coins minimum. To make 7 rupee, you will need minimum 3 coins if available denomination is 1 and 3. Now we are going to the next row. That means we now have 1 rupee coin, 3 rupee coin, and 4 rupee coin. Okay, 3 options we have, 3 types of coin we have, 3 denominations we have now. Now let's see how it is doing. Okay. Fine. Same thing. Let's start. Now I'm here to make 1 rupee. Can I take a 4 rupee coin? I am at this row, right? Can I take a 4 rupee coin? The answer is no. I cannot take a 4 rupee coin. Just copy the previous value. Just copy the previous value, that is 1. Similarly, guys, here I want 2 rupee. Can I take a 4 rupee coin? No. Just copy the previous value, that is 2. Same thing here. I want 3 rupees. Can I take a 4 rupee coin? Answer is no. Just copy the previous value, that is 1. Now I want 4 rupees. Can I take a 4 rupees coin? Answer is yes. Now let's calculate. So I want 4 rupee. I will take one coin of 4 rupees. Remaining amount is 0. So what is the remaining number of coins I need to make the remaining amount? Same thing, I just in the same row go to the column 0 and take up the value, that is 0. So the answer is 1. You need only one coin to make 4 rupees. And which is minimum? Previous value is 2. Now we got 1. Minimum is 1. And yes, it's quite correct. I take one coin of 4 rupees and total it would make 4 rupees. So minimum number of coin to make 4 rupees is 1. Okay. Now similarly here at this, I want now like to make 5 rupees. The question is, can I take a 4 rupee coin? Answer is yes, I can take a 4 rupee coin. So let me write it here. So I want to make 5 rupee. I will take one coin of 4 rupee. Remaining amount is 1 more rupee. So what is the remaining number of coin required to make 1 more rupee? In the same row, we'll come to the column 1. The value is 1. So one more coin, guys. Total is 2. What is the previous value? Previous value is 3. Minimum is 2. So we have taken actually one 4 rupee coin and one 1 rupee coin. That's it. Okay. Now similarly we are at this column 6. So can I take column 6 means 6 rupee I want. Can I take a 4 rupee coin? Answer is yes, I can take. So I will take one coin of 4 rupee. Remaining amount I need is 2 more rupee. So what would be the remaining number of coins for making 2 rupees? The remaining amount, just in the same row come to this column of 2. You'll find the value there. That is the number of coin you need. That is the minimum number of coin you need to make 2 rupees. So that is 2. Total number of coin is 3, guys. Previous value is 2. Now we are getting 3. Minimum is 2. You will not write 3, rather you will write 2. Okay. Whichever is minimum, you will write that. Because the problem is about minimizing the number of coins. Now similarly, you are at this column 7, that is 7 rupees you want. So I need 7 rupee. I need 7 rupee, guys. Can I take a 4 rupee coin? Answer is yes. If I take one coin of 4 rupee, remaining amount is 3. Okay, I need 3 more rupees. What would be the remaining number of coin? Same thing, you do the same thing. In the same row, come to this column where come to the column number 3 actually. Okay, where you need where you'll get the value, where you'll get the number of coins to make 3 rupee. That is 1. So 1 plus 1, that is 2. What is the previous value? 3. What you are getting now? 2. There is 2. Okay, right? Answer is 2. You are getting. Okay. Similarly, you just have to repeat the next step, guys. So this one, to make one, so now you are here. That means you have 1 rupee coin, 3 rupee coin, 4 rupee coin, 5 rupee coin. To make 1 rupee, can you take a 5 rupee coin? No. Copy the previous value. To make 2 rupee, you cannot take the 5 rupee coin. Copy it. Copy it. Okay, just copy the previous value, because I cannot take a 5 rupee coin to make 1 rupee, 2 rupee, 3 rupee, 4 rupee. Now you are at here. Now you are here, you need 5 rupee. Okay, you need 5 rupee. Can I take a 5 rupee coin? The answer is yes. Okay, I can take a 5 rupee coin. Just give me one moment, guys. Let me clear this out. solve. Just 3 more cells we have to put and the answer is done. We'll get the answer. Okay, yeah. So I need 5 rupee. Can I take a 5 rupee coin? The answer is yes. If I take a 5 rupee coin, the remaining amount is 0. What is the number of coin to make 0 rupee? Just go to the 0 column. The value is 0 there. So total 1 coin I need. What is the previous value? 2. What is the new value? New result 1. So you will write the new value, the minimum one. Whichever is minimum, you will take that. Now you are at here, you want 6 rupee. So can I take a coin of 5 rupee? Because you are now at this row. Yes, I can take a coin of 5 rupee. Remaining amount is 1. So the remaining number of coin is 1 plus, go to here, that is 1. 1 plus 1, 2. Previous value is 2. Current value is also 2. Write whatever you want. Minimum is 2. Now this row, 7 column actually. You need 7 rupees. Can I take a 5 rupee coin? Answer is yes. I can take a 5 rupee coin. The remaining amount is 2. So what would be the remaining number of coin? Go to the column 2. What is the value there? Is 2. So you will take 2 here. You are getting 3. What is the previous value, guys? Previous value is 2. Now you are getting 3. Minimum is 2. So write the minimum value here. And guys, this is the answer actually. Okay, this is the answer. The last cell. This means you are at the last row, means by taking 1 rupee coin, 3 rupee coin, 4 rupee coin, 5 rupee coin, in order to make 7 rupee, the minimum number of coin is 2. Okay, this is how you apply dynamic programming. This is how you get answer to this minimum coin change problem, guys, which Greedy was not able to solve. We are getting here 2. The correct answer is 2. If you take a 4 rupee coin and 3 rupee coin, that will make 7 rupee. Okay, if you follow the Greedy approach, then what would happen is Greedy will take a first 5 rupee coin. Okay, then for remaining 2 rupee, it will take 2 1 rupee coin. So that would make it total 3 coins. Okay, which is wrong. But dynamic, here in dynamic programming, we are getting answer as 2, which is correct. I hope everyone got this session, guys. I hope everyone understood this problem, this minimum coin change problem, by using dynamic programming, also using greedy programming. Also, I hope you have understood the greedy florist problem, understood the technique, how we apply the greedy algorithm, and what happens actually, what principle is followed by greedy approach, and what principle is followed by dynamic programming, how actually we solve these dynamic programming problems. In an interview, if anyone asks you this minimum coin change problem, if the interviewer gives you some denomination and some amount, and the interviewer will ask you what would be the minimum number of coin to make this amount. So what you have to do, you have to just draw this table and do this calculation stuff, whatever we did, and finally just have to give him or her an answer. This is the minimum number of coin. Okay, clear everyone? If it is clear to everyone, then we are done for this session, guys. This was the remaining thing which we had to do, the greedy and dynamic program, and we are done with that. Is it clear to everyone? Clear? Please let me know in the comments, guys. Maybe you can put some emojis to show that it is clear. If it is clear, please let me know. Please let me know, guys.
Recent decades have seen a dramatically accelerating pace in the development and adoption of new technologies. But a gap persists in terms of adaptability. What if you can fill that gap from the comforts of your home by upskilling? Introducing PGP Full Stack Program by LetsUpgrade. The most affordable PGP Full Stack program has everything that will take you to the next step of your career via learn, build, share, grow. You earn a PGP Full Stack certificate accredited by ITM Group of Institutions and STC, Skill India. LetsUpgrade.in.
Learn the most demanded skills in industry with 2 years of Python, Django, AI/ML deep learning, data science, web development with React.js, Vue.js. You may pick any one of this track, but you will do System Design, Problem Solving DSA certification, Cloud Computing certificate also. Be the one that top companies are looking for.
Okay, so guys, like that's it for this day 3 master data structure and algorithm with C++. I hope you understood greedy algorithm and dynamic programming, guys. I hope you understood these two or three problems, whatever we did. Greedy florist, through greedy algorithm we did this minimum coin change problem by greedy, also by this dynamic programming, right? Okay, we understood the various aspect of greedy and dynamic. We understood that where greedy is applicable, where dynamic is applicable, what principle is followed by greedy, what principle is followed by dynamic, right? Okay, this is the whole thing, guys. This is the whole agenda for this day 3 master data structure and algorithm with C++. We are done with it, guys. Okay, one more session you have, guys, that is on I think on Tuesday you have one more session, that is your career and placement guidance session. You please all do attend that. Okay, also put attendance for that, because you know, right, the certificate participation and completion. Okay, for certificate you need to find, like, you need to fill attendance for all these session, for all these 3 plus 1 4 session. Fill the attendance, fill like attend that session. That is also very useful for you guys. There you will be guided for the placement preparation and all. Please do attend that. So see you all, guys, in the next class. Maybe I'll not be there. Some like Sneha ma'am would be there talking about the placement and all preparation. But see you like somewhere in some other program. I think in 16 September we are coming up with Java program. I'll be there. I'll be taking the Java program there. Java programming concept. If you want to learn the fundamentals of Java programming, be there, guys. 16 September. You can also register for this. You can visit our website, that is letsupgrade.in, and you can see there. You can get the link for the Java programming and you can enroll for it. If you have not get it, if you are not getting it, just give me a moment. I'm putting the Java programming link here in the comment. Just give me one moment and I'll be putting it. If you want fundamentals of Java programming, if you want to learn Java, guys, from scratch, please do register for this Java programming course, which is coming up 16th of September. Okay, timing I think it will 30 or something. You'll get it. Okay, when you register, you'll get all the details actually. Okay, I'm giving you the link in the comment. Just give me a moment. Yeah, I got it. Yeah, you can register for the Java programming course, guys, on this link. I have pasted it, like I posted it here in the comment. Let me also pin this if anyone wants. Yeah, so that's it, guys. That's it for this session. I hope you enjoyed this session. I hope you understood everything, whatever has been covered in all these 3 days master data structure and algorithm with C++. Okay, so guys, like, keep practicing, keep learning. Whatever you're done, just code that greedy florist problem in hacker and go there and code it. I hope you can do it after we have discussed the solution. Okay, right? So keep learning, guys, keep rocking. Till next time, bye bye and take care. Okay, let's meet again in the programming session.